In the chemical properties, first we will deal with the reaction with oxygen, that is complete combustion. When hydrocarbons are burnt in oxygen, in excess of oxygen, carbon dioxide and water will be formed. Methane and ethane, they burn in excess of air with a bluish non-sooty flame to form carbon dioxide and water vapor, and large amount of heat energy is given out. So alkanes are good gaseous fuels. Now we will learn the reaction of alkanes with halogens. When methane gas reacts with chlorine, the substitution reaction takes place. In the presence of diffused sunlight or 600 Kelvin, the one hydrogen of methane is replaced by chlorine and it will form CH3Cl, and along with that one molecule of HCl will be formed. In this reaction CH3Cl is formed. This type of reaction is known as substitution reaction, and the product formed is known as substitution product. Now the product formed, chloromethane, further reacts with chlorine, substituting one more hydrogen atom and producing dichloromethane. This further produces trichloromethane and finally tetrachloromethane. Trichloromethane is also called as chloroform, which show anesthetic effect. The substitution products can be separated by fractional distillation because of the appreciable differences in their respective boiling points. The decomposition of a compound by heat in the absence of air is called as pyrolysis. And when pyrolysis occurs in alkanes, the process is termed as crackling. The alkanes, on heating under high temperature in the presence of catalyst or in the absence of air, are broken into lower alkanes, alkenes and hydrogens. As I have shown you, ethane. Ethane, when burns in the absence of air at 500 degrees Celsius, it will give rise to ethene along with methane. So lower alkane will be formed along with the double bonded compound. And when pentane, heptane, they are burned, they also will give rise to one alkene and one alkane. So lower alkane will be formed, and along with that an unsaturated compound will be formed. Uncontrolled or catalytic oxidation, alkenes give alcohol, aldehydes, carboxylic acids depending upon the reaction conditions. When a mixture of methane and oxygen in the ratio of 9:1 by volume is compressed to about 120 atmospheric pressure and passed over copper tubes at 575 Kelvin, methyl alcohol is formed. Then, when it is passed to molybdenum oxide, it is oxidized to formaldehyde. On the other hand, when a manganese-based catalyst is used at 100 degrees Celsius, methane can be oxidized to formic acid. Similarly, ethane also oxidizes to either ethyl alcohol or acetaldehyde or acetic acid, depending upon the catalytic condition.